Okay, let's begin. Hi everybody. Welcome to this session about stream processing, one of the hottest topics we see right now at our customers, and I will today tell you about some different use cases from different industries, and then of course different options how you can implement that in your projects. My name is Wähner. I work for TIBCO. I live in Germany and I do talks at conferences worldwide, and I love to be here in Göteborg today for this session. So I usually start with the key takeaways from my session. So if you leave the session in 45 minutes, then I think you should remember 3 things afterwards. The first one is that streaming analytics, or stream processing, which is a synonym, is used to process data while it is in motion. So really act on the data while it is happening. That's really the key concept of stream processing, and very different from the database approach where you write something to a database and later you do a request to get the information back. Here really process it while it is in motion. The second important part about stream processing is that it's about automation, machine-to-machine communication, but nevertheless you also need proactive human interaction on top of that, because for many use cases it's important that still a human makes the last decision. And the third message is that streaming analytics is complementary to many other big data concepts and solutions like Hadoop, like Apache Spark, like machine learning, and many others. And I will also talk about that in detail. So the agenda for today: first I will take a look at real-world use cases from different industries, that you get a little bit about idea what I'm talking about. And then I will give a short introduction to what I mean with stream processing. And then the key really is to talk about a market overview of different open source frameworks and commercial products for stream processing, and also talk to it about how it is related to other big data components like Hadoop, for example. And in the end, I will also give a short live demo that you can get a little bit of feeling how that looks in a real-world project. Let's begin with 2 different real-world use cases. To give you an overview, stream processing, that's really to act while the data is in motion. So while there's still what we call a window of opportunity. So for example, if you take a look at the left, if you think about seconds, you really should act while the fraud is happening, so that you can react before the fraud happened. Or if a customer is still in the store, you want to cross-sell something before the customer has left the store. Right? Because when he has left the store, he is buying it and spending his money somewhere else. So you want to act proactively before he leaves it. And the same is also true for longer running processes. So it's not always about seconds, but sometimes it's about minutes or even hours. For the hours example, it's about, for example, about predictive maintenance, which is one of the hottest topics for using stream processing, to replace machines before they break or explode and things like these. Though this is the basic overview to show you that it's really important in every industry. We have industry customers from banks, from logistics, from retailers, from manufacturing, from automobile. Really everywhere this is coming more and more, to act in real time while the data is in motion. Let's take a deeper look into 2 different use cases. The first one, as I said, one of the hottest topics is predictive fault management. And here, the specific scenario which I want to talk about, and this is also the one I will show you in the live demo at the end of the session, is about an oil company. And they had the following problem. They have had an outage on one well, can cost them $10 million per hour. And they had 20 to 100 outages per year. So you can see a business case here. It's a lot of money they have problems with. And what they are doing now, they are taking a look at all the different data they have. So this oil platform has a lot of sensors which generates data all the time, really millions of messages every minute. And from many, many different interfaces, and the information is coming, right? And they are gathering all this information to find patterns in that. That's the historical analysis of data, to find patterns. But after you have found these insights, then you have to act proactively in the future to predict if something will happen again. And what they are doing now, they are predicting if a machine will break and explode, and then they will replace it before that. And that's really the key goal of predictive analytics usually, to save a lot of money and to look somehow into the future. Of course, it's always just about probability, right? So you cannot say for 100%. But even if you think about 80% probability, if the explosion costs $100 million and the replacement of a machine costs only $100,000, then even with 80% probability, you do the replacement usually. And therefore, what you do then, after you have found the insights in historical data, you have to implement that in real-time processing. And in this case, it's a very simplified scenario, of course, here for the explanation. But here we have 3 different sensors. One is for voltage, one is for temperature, and one is for vibration. And the rule which is defined here, though, that you should send an alert is the following. So if a vibration spike is followed by a temp spike and then a voltage spike, and this thing within 4 hours, then flag a high severity alert. So here, this is really what stream processing means. You really act on the data while it is in motion, and you correlate the different sensors to get this information and to act proactively. And here, in this case, after this pattern happens in a sliding window where you always take a look at the last 4 hours. So it's not a request and response where you take a look at the database every minute or every 10 minutes. You do continuous queries on that to find these patterns. And then you send out an alert. And that's also why I said in the beginning, as one of the key takeaways, it's not just about machine-to-machine communication, because even if the replacement usually makes sense in 80%, all right, it's not always a reasonable decision, because it still costs 100,000 for the replacement. And though there's still a human interaction by this live UI, where the human can take a look after he gets this alert to make the final decision if the replacement has to be done. Right, so that's the first use case I want to show you to get an understanding. Stream processing for predictive maintenance. And the second one is a completely different one to show you that it's really relevant in all the different industries. And this one is more from sports and retailing and so on, and it's more about crowd management and making the customer happy and cross-selling and all these things which are important in these kind of industries. And here really the goal is to, okay, now my PowerPoint broke. We all like Windows. So let me start it again. PowerPoint. This should not happen usually, but it's hopefully not my fault. Let's go back here to the crowd management use case and begin once again here. So in this use case, it's about to turn the customer into a fan and increase their revenue significantly, of course. It's not working? Okay. And so that's basically the idea. In the first case, of course, you want to make the customer happy, but on the other side, of course, in the end, a company wants to increase its revenue on the long term, right? And the use case here is about the Sacramento Kings. It's an NBA basketball team in the US, and they have built their new stadium last year, what they call now the world's smartest building, because everything in this building and also with the other interfaces of outside the building are connected to each other, to correlating the information in real time. So here it is really when the fan drives to the stadium, he already sees on his app where to go, where is the fewest traffic, what's the best parking lot to go for his seat. And then while he's walking to the stadium, there's a lot of beacons everywhere which know exactly where he is and what to do with him. So for example, if it's a loyal customer and if there are VIP seats available for this game tonight, then he gets an automatic short message to his mobile phone. Hey, dear customer, because you spend so much money for us, you get now a VIP coupon for 50%. You can buy the VIP ticket if you want. But you have to decide in 30 minutes because after the game starts, this doesn't make any sense anymore. And like this, all is connected. So after the game ends, the customer or the fan leaves the stadium, and there's also other systems integrated from partners, for example, from restaurants. And if you see there's a steakhouse next to the stadium, and besides that, you correlate the other information like it's raining outside a lot, and also the restaurant has a lot of free seats, and in the kitchen, you know, they have a lot of steaks available, then you correlate all this information in real time, and before the customer walks away from the stadium, he gets another message, dear customer, today you get 70% for your steak coupon. And like this story, which is already implemented and deployed here, and in many of our other customers, all the different systems are integrated for correlating all this information in real time, as you can see here. So we have so many different systems. It's the legacy systems from the company, and also it's cloud services, but it's also partner systems. And all of that works together to implement these patterns in real time. And the two key things here is really to give more context and to do it more personally. So really to give every single customer what he wants to do, because then you make him happy and you increase your revenue. And that's just another story how you can use stream processing to add business value in the end. And we have these kind of stories for every industry out there in the meantime. And now the question is, after I've shown you a few use cases, how do you realize that? Because here we are a technical conference, that's the most important part, of course. And the key here really is, in the end, it's two things you have to do. The first one, as I mentioned, you have to take a look at the historical data. And therefore, all customers or enterprises in the meantime store all their data. That's what we call big data, right? You store it in Hadoop or in another big data store to analyze data afterwards to find the patterns. That's the first step. I will talk about that later also in the end, but that's the first step. And after you have found the patterns, then you can bring them into action. That's what we call fast data in our customers, but that's in the end stream processing or streaming analytics or event processing. So the branding or the term does not matter. In the end, it's about correlating events and taking action in real time on that. That's really the key how you have to realize it. And for that, if you take a look at the architecture, in the end, it looks here very complex, but it's not, and I will come back to the slide later in more detail. But in the end, you have to understand two different things of this complete architecture for big data analytics. In the end, you have two parts, is the analysis of historical data. You have a big data store like Hadoop or a data warehouse, and you find patterns in that with a historical analytics tool like Spotfire, or you use machine learning, things like R or Spark and so on to find the patterns. That's the first part, right? And then the second part is the event processing part, where you do the automatic machine-to-machine communication for event processing, and also the live UI on top so that a human can interact if necessary on that. So that's basically, to keep it simple, the two parts of a big data architecture you need. And now let's first take a look at the stream processing part of that, which is in the end the key of this talk today. If you have found the patterns, how to bring them into action in real time. And so, as I said in the beginning, streaming analytics or stream processing, it's really, you have all these inputs of streams all the time, in seconds and milliseconds, whatever the time is, you get this, but then you have to analyze them while they are in motion. And that's really the key difference to things you know, like web services and database calls and Java function call and all that stuff. Because here you therefore also have some other concepts. So the key really is the continuous queries and sliding windows. So that you always, for example, take a look at the streams of the last 10 seconds. So it's not always a request response every second or so. It's really a continuous query. And therefore, if you take a deeper look at the technology under the hood, what's running there is in the end SQL similar. So we have also query language under the hood. Depending on the different framework or solution, it looks different, but in the end it's a query language similar to SQL, but it is not SQL because you have additional functions in there, which in the end implement these features like continuous queries and sliding windows. And that's in the end you have a query language with these features, and then you can analyze it continuously. That's in the end the basic under stream processing. And as I said, it's machine-to-machine communication. That's the key because usually you're really talking about millions of messages. So we have, for example, at TIBCO have messaging solutions which can process 8 million messages a second, right? Because you need that for Internet of Things and these kind of technologies. But nevertheless, for many use cases, it's important that you also have a live UI. And this, again, is not request response or something like this. Here, it's really the data is pushed into the UI. And of course, you cannot push all millions of messages. That doesn't make sense for a human. But you only push the important ones. For example, the errors or the exceptions or something like this in real time to the UI. So that's basically what stream processing is. And now let's take a look at the market overview and the different options how you can implement that. So if you take a look back at our architecture, this is really now the part about the event processing or stream processing in real time, right? That's what we take a look at. And if you want to implement that, you have 3 different alternatives. The first one is just using the streaming concepts. The second one is streaming frameworks. And the third one is streaming products, what I call it here. And always the important thing is here, if you use a streaming framework, it always includes the concepts here. And if you use a streaming product, it includes the concepts and the parts of the framework. And now let's take a look at all of these 3. The first one is very short. It's the streaming concepts. That's in the end what I already explained about these things like continuous queries and sliding windows. And you have patterns for counting and sequencing and tracking and trends. That's the concepts. And what you could do, you could implement a solution by yourself. But to be honest, that doesn't make any sense because there are a lot of different open source frameworks available and the Apache license, so you can use them wherever you want and do whatever you want to do with them. So I have never seen an option where someone built a streaming processing solution by themselves, and I personally would not recommend it. Because, and now we come to the second option, which is the frameworks in the end. So let's take a look at the alternatives you have if you do not want to implement it by yourself. In the end, you have 3 sections, and the first two are the frameworks. For the frameworks, you have the open source frameworks like Patchy Fling, Apache Spark streaming, or Apache Storm. And you also, in the meantime, have a lot of cloud services available, like Kinesis from Amazon Web Services or Azure Microsoft Stream Analytics. So even these are offering some kind of streaming frameworks. Now that's the first option you have, to use a framework, either open source here, or use a framework from one of the cloud providers. That's the 2 options you have here. And if you take a deeper look at what these streaming frameworks offer you, then you see here the different, let's say, characteristics which you have if you use an open source or a cloud framework for stream processing. In the end, that's a library for Java or .NET or whatever library is available, and you have to code on that. And that's absolutely fine if you want to do a project where you write the code, but that's in the end really the key specific thing of a framework, that you write the code. You add the libraries and implement your solution with these frameworks. They then have methods which you can call for the streaming queries and continuous queries and so on. You have the query language I already explained, which is similar to SQL, but with additional streaming features. And usually these streaming frameworks are built for scalability, and they offer a lot of connectivity. Because no matter if you use just a framework or what we see later, product, you need to connect to all the different systems. Internet of Things, or even social feeds, or finance trades, or whatever you want to integrate for correlation in real time. You have to connect it first. And then you have, as I said, the operators for filtering, sorting, aggregating. That's again, in this kind of framework, it's usually just a method or operation which you call with your parameters, and it's implemented for you under the hood. And that's the reason why you should never implement it by yourself, in my opinion, because the frameworks already offer all of this to you out of the box. If you use an open source framework, it's for free. So let's take a look at a few of them. I will not go into too much detail. It's really just an overview session. The first one is Apache Spark. It's a very major one, which was created by Twitter several years ago. And this really created the idea of stream processing. And like it is always, the tech giants like Twitter and others built these frameworks by themselves because they were not available when these tech giants needed them. In the meantime, where every enterprise needed it, that's the good thing, that these tech giants publish it for open source so that you can use it. And really, I do not want to go into detail, so it's not important that you cannot read the code. It's just about the concept that you have inputs and then do processing, and then you have some outputs. And the key message here is really you have to code that. And that's fine again, it's a trade-off, always tooling versus coding. But that's the basic idea behind frameworks like Apache Storm or Apache Fling or something like this. On the other side, you have the cloud services like Amazon Kinesis. The cloud services have some similar parts like the frameworks open source and some differences. The similarity is that you also have to write the code in a similar way. You have your API and you write the code to do the stream processing. But besides that, The benefit is that it's very well integrated into that cloud provider, of course. So if you use a lot of other Amazon services, like S3 for storage, or the container service, or MapReduce, or whatever, then it might make sense to take a look at this because it's very well integrated into this cloud platform, of course. And also, what's a benefit compared to the open source frameworks like Storm is that you have a lot of UI where you can do configuration. It's a typical Amazon AWS UI, which you have for every product there. If you think about using one of these cloud frameworks like Kinesis, then you have always been aware that this is in the end a software as a service where you do not have the full control. I've added here a really interesting blog post which describes this in much more detail, but in general you can remember really like in all cloud solutions you have no control, you have to accept what they offer you. That means, for one example, that you do not have all the features available like in Storm, and you cannot extend it like you want usually. And on the other side, it's also about things like scalability and service level agreements and so on. You just can use whatever the cloud provider offers to you. Besides that, there's a lot of different frameworks available on the market. So one other one which is getting more and more traction, we also see that at our customers more and more, it's Apache Spark. Spark, which is a general data processing framework. And as you see here, one part of it is stream processing. So in general, what we see at customers usually, mostly Apache Spark is still used just for the analytics part. So that means if you take a look back here of the components, most of the customers we see especially use Spark for machine learning and for SQL to do analysis of data. Spark streaming is not so much used, at least not used yet. I've added a lot of links. I will not go through them a lot, but the key really is today, as we see it, Spark streaming is not used that much. One of the reasons is that it does not real event processing. So it does not process every event by itself in motion, but it's doing some kind of micro batches. So it always takes some events and then process them like ETL, right, in one batch. And so that's also a problem often for performance and for them other architectural concepts. Nevertheless, one of the good reasons of Spark, of course, is that it's a part of the complete Spark framework. So if you use the other things of Spark, like machine learning and like SQL and graph database and so on, then you can combine it easily, of course. That's the huge benefit of Spark streaming. So here, if you see the Spark Core API, and then you see the Spark Streaming API, without going into detail here, then it's very well integrated because it's one framework. And that's the huge benefit. So if you should, in my opinion, think about Spark if you want to combine Spark streaming with the other parts of Spark. Otherwise, all the other options probably are a better solution for just doing stream processing. And the last one I want to discuss here is Patchy Fling. Patchy Fling, if you take a look at the features and components, it looks very similar to Spark. But the difference is that its idea is streaming first. So that's really, it's a newcomer which is not available as long as Spark, but the basic key difference to Apache Spark is that it's doing streaming first under the hood instead of micro batches. And therefore, for these use cases, it might be the better option, but it's not as major as Spark, for example. So that was an overview about the different open source frameworks and also about a little bit the cloud solutions available. And next, I want to talk a little bit about the products available. So products are, for example, from TIBCO where I work, it's TIBCO StreamBase, or IBM has IBM InfoSphere Streams, Software AG has Apama. So all the middleware vendors have their stream processing product. And so now what's the difference now between the frameworks we just talked about and the products? So as I said, the products have all the concepts and all the framework parts like library, query language, scalability, connectivity. That's always the same, often even better because the commercial products usually have more connectors and more powerful operators and better performance often and so on. But the key differences are here on the right side. So what you see, for example, and I can show you that for a minute later, is that you have a visual IDE. So here, often people I talk to say that, well, that's never working and we prefer coding. And I have no problem if someone wants to code, but the key difference is really time to market here. And in contrary to maybe 10 years ago, when people have taken a look at visual coding. Today it simply works, right? That's the difference to 10 years ago. And there are a lot of features out of the box, like simulation and feed testing and test generation. You can do these kind of things without coding. Or also one of the important parts, like the live UI. That's things you can either code with HTML and JavaScript and some frameworks, or you have it out of the box with a product. And other reasons why we see customers using it instead of an open source framework often is things like maturity and the 24/7 support and consulting and all of that stuff. And also, of course, if someone is already our customer and uses, for example, our ESB or BPM, then this is very well integrated. That's just the differences between a product and between a framework on the other side. It's again always simply a trade-off between the one and the other. What do you like? What do you need? Do you want to code? And so on. So here's just a screenshot for one example, IBM InfoSphere Streams. That's the product. Another one I can take a little detail look because it's our product is TIBCO StreamBase. And here again the basic idea is simply that instead of writing the code, you just use the components and drag and drop and configure them. That's basically the difference. So if you want to implement, for example, a sliding window for 10 seconds with several different rules, how to correlate different events, and if you want to integrate MQTT and several other IoT sources, then you do it here with just components and configuration, and with Java code you have to code it and use the connectors and so on of the Java framework. And also for the debugging and so on, it's simply, if you've maybe used any other tool like an ESB or BPM or whatever, the difference is simply one is just coding and the other one is the tooling on top of that. And what's also important then, no matter if you build it by yourself with frameworks, with JavaScript and HTML, or if you use a product, as I said, it's important that you also have a live UI. That's very important for many, many projects. So what we call it is live data mart, and so here it's really the name because it gets all the different data live and does the continuous queries with all these different sources, and then it pushes these data into a real-time UI where you can of course monitor it in real time because it's these continuous queries and you get alerts and so on. But what's also very important is that you also can do actions here. So depending on what you have configured or implemented, you can do a right click and do something. So for example, if you think about the predictive maintenance use case with the oil platform, if you see that a machine probably for 80% will break soon or explode, then you might take here an action and, for example, stop the machine and send a mechanic there. So that's the reason why you often need a live UI on top of the stream processing. And what we also see often is that frameworks and products are combined. So we have a lot of customers which are using things like, for example, Apache Storm for really processing the operational data, maybe deployed on Hadoop or somewhere else. And then they use a live data mart on top of this data, right? So they have, for example, already implemented the stream processing with Apache Storm and connect this one to a TIBCO Live Data Mart for implementing the UI on top of that. So we see that very often that different products and frameworks are combined. In the same way you see it in the open source world where all the different frameworks are combined. I mean, in the framework world, you have to do it usually. So you have to combine the different frameworks. And so often we see it in the same way that people combine frameworks with products. So this is in the end an overview about stream processing. So the key here really is on the one side you have open source frameworks where you code a lot. Then you have the cloud solutions where you have a lot of out-of-the-box options. You still have to code a little bit, but you don't have the feature richness of the open source frameworks. And on the other side, you have the products, which are usually more powerful and, let's say, easy to use, and you do not have to code. But therefore, of course, you have to pay a license fee or subscription or whatever. You have to pay some money to the commercial vendor. That's in the end the key differences, I think. And now let's take a look again about the relation to the other big data components, because event processing alone often does not make very much sense. So in most of the use cases at our customers, they combine it with the analytics part. And that's again here the lower part here. So what do you want to implement with stream processing if you do not know any patterns to implement in real time? And it's important for all the use cases. If you want to do fraud detection, you first have to learn what is a fraud in the past, right? If you want to do cross-selling to a customer, you first have to learn what do I want to sell to this customer in a personalized experience with the right context at the right time. And again, also for predictive maintenance, if you think about it. How do you want to predict if some machine breaks or explodes if you have not taken a look at the history? You never know when it will break. And therefore, it's important to combine these two concepts. And first, you store all the historical data from the sensors and all the other incoming information. And you store it, or big data store like Hadoop. And then you use any kind of historical analytics to find the patterns inside that. For that, you can use tools like, from TIBCO, it's TIBCO Spotfire, or some others. And you can also combine it with things like machine learning, where you build analytic models with R, or with even proprietary vendors like SAS, or Spark, MLlib, for example. And you can combine that all to find the patterns in the historical data. And then after you have found it, you can bring it into action in real time to prevent it in the future, or to cross-sell, or to do anything. That's in the end this closed loop, which is very important to understand, that you first have to analyze the data, and then you create a model, a pattern, an insight, and this model can then be deployed into real-time processing to stream processing. That's in the end the basic story. So you really store everything first, because even if it's without structure and whatever it is, that's one of the reasons why we have Hadoop today. And after you have stored all the data, you can understand and anticipate it using tools for data discovery with visualization, with other things like machine learning. If you need a data scientist, if it's really more complex data to look at, then the business user we usually use as the visualization, he cannot implement the analytic models using R or SAS or something like this. So usually it's a combination of a business user, which also has a lot of knowledge about his business field, and a data scientist, and they together find the patterns, and after they found a pattern, they bring it into action. So here now we come again back to streaming analytics, or event processing, or stream processing, to bring it into action. So here you see stream processing. It can take any analytic model or insights, no matter if you have to implement it by yourself, or if you use an analytic model like open source R or H2O, which is another open source library we see more and more. It's also based on Hadoop and Spark. Or if you use MATLAB or SAS, for example, as a proprietary commercial product for building analytic models. So let's take another use case here to explain this once again. So what we see this a lot is in the betting sector, where you do sports bets, for example. And this also has changed a lot in the last year. So today, what our customers tell us is that at least 80% of betting happens after the game begins. And that's also a very important story for the combination of things like Hadoop, for big data processing, and also for the event processing. So let's first think about the big data stuff. Before a game begins, it's very easy, because you can do MapReduce jobs and big data processing and analyze terabytes of data, and it's no problem if this processing takes an hour or even overnight. And with that, the betting vendors calculate the bets for the game of the next day, right? And you can do that bet, and you can also calculate the changes before. So, for example, if a player gets injured or all that stuff, then you have the bets for the game. That can be done in Hadoop or Spark and can take hours to compute overnight. And then you have the bet for the game. But then the game starts. And then we have the problem that a lot of other events happen. And that's happening in real time. Like a score is happening, or an injury or something like this. And then, because a game is only 90 minutes or 2 hours or something like this, you cannot start another long-running MapReduce job in Hadoop. But then you have to use the event processing part to act in real time on new data. And that's, I think, a very good example where you can see how you combine the historical analytics and big data processing, which takes long term, in combination with then adding new events in real time. Because here, really every second counts then to change the bets. So it's even very important to integrate in the meantime things like Twitter and Facebook and all these social feeds to exactly this story and many other use cases. So if you think about this betting story and a live running game, and if a player gets injured, and what I'm usually using here is an example from the US, from football, because I have seen that live. And it's a little bit more important than, for example, in soccer, which is more important in Germany sport. Because in football, the quarterback is the most important player of a team. And there was a situation where Tom Brady, which is the quarterback of the New England Patriots, got injured in a game. And after such a player gets injured, the odds change dramatically, right? And if you see that in a stadium, or if you read a Twitter feed about that, and you bet money on that before you are able to change the odd, then you can earn, or at least you increase the probability a lot that you earn a lot of money. And therefore, the betting vendors also have to integrate this and process it in real time, so that they can change the odds, or at least stop betting on these odds before you can earn a lot of money with that. Right? So that's a very good example, I think, for stream processing in combination with Hadoop and that. And here again, you also have a live UI on top of that, because it's about so much money and so much business behind it that there are still humans in that, which can take a last look at these things and make the final decisions. So this was, in the end, an overview about stream processing and also how it's related to Hadoop and the other big data components. And now let's take a short look at a demo, how this looks like in a real-world project. And what I want to show you is, again, this predictive analytics story about the oil platform, which is analyzing the different sensors and finding patterns to bring them into action to replace a machine before it explodes. And what I want to show you here is really, in the end, the complete story. So not just the stream processing part, but really the complete story. Hopefully we see it. Yes, we see it. So the basic idea, how this starts in the beginning, is that a business user is taking a look at the historical data of the sensors using some data discovery tool. Right? This is now TIBCO Spotfire. Of course, you can also use other tools for that. But here, they import all this Hadoop data, so really terabytes of data, to analyze this and to create many very interesting different visualizations, which are interactive and where you can drag and drop and filter and so on. And this is really important for the business user, because here the business user can spot the problems. As an IT expert, I cannot see much in that, at least not what's the problem or so. So the business user uses this one to find some initial problems, and where he thinks there are some problems. But based on that, usually the data scientist comes into play, because this is so much complex information that it's too much for the business user to find the patterns. And therefore, we often see this in combination with the data scientist, who helps him. So he also analyzes this data with the background of the business analyst, who gives him some information. He has taken a first look and so on. And then there comes the data scientist, which uses another tool. So in this example, I'm using just R, which is getting more and more important for machine learning and data scientists. And he uses some tool like, for example, here in this case, it's the R Studio, an open source IDE for the R platform. And with that, the data scientist created a model. So in the end, what is a model in R? A model in R is, in the end, an object which is stored to disk or somewhere else, which contains the algorithm which is the pattern in the end which you implemented, and it was trained with training data. So the training data is the historical data. And now here, with the training data and the algorithm, he has built this model, which is an R object. It's a file, right? And this algorithm here, this model, is used back in Spotfire in this case, or in any other data discovery tool which supports that, so that you here, if you change any of the drag and drop and filter and whatever you have configured, this recalculates the visualization using the analytic model under the hood. Right? So here again, under the hood, it could be R, it could be SAS, it could be H2O or Spark or whatever. And in this combination, the business user can now find more insights. And in this way, they work together to find the final pattern, which should then be deployed to runtime. And then, now we're coming to the stream processing part. Let me first start it before I explain it to you, because on this machine it's a little bit slow. So I will first start it. And so here now you see, for example, TIBCO StreamBase as a stream processing IDE, where you do all the visual development. And I will not go into too much detail, but the basic idea is that you drag and drop the different components for both for the connectors, for MQTT or RabbitMQ or specific Internet of Things connectors or whatever you want to connect to. And then you process them in real time. So here really you again configure these continuous queries within these components. So for example, here we see one component where you define different, in the end, sliding windows. So this is really a demo use case where it's very simple. So this really uses a sliding window of 3 events all the time. In the reality, it's much more complex rules, but nevertheless, they are all configured here. And then you define different aggregations here which you want to see, for example, maximums or minimums. And again, this is much more complex stories in the real world. And you group it by, for example, the well ID in this case, because of course you have to group it that you match the right information with the right one. And then you get all new events in real time into this stream processing process and do your aggregations and correlations. And then you can, in the end, send an alert out if one of your patterns is matched, right? And you can do either automatically, for example, stop the machine in this case, if the probability is more than 80%, or you can send it to an UI, which I have, I will start now. I hope it's already running. Let me see. Yes, this looks good. And now we see the live view desktop. So in our product there are different options. This is the rich client, which is a Java Spring application. You can configure everything without coding. But there's also a web client, and you also, of course, can use a JavaScript API to get this information. And in the back, this is running now a simulation. And this simulation is creating feeds. And here, everything red always is an alert. So it's a little bit more quickly to show the demos. But this is, in the end, a real-time view on your streaming events. And what's very important again, it's important that you cannot just monitor it here, you can really take actions. Like you configured it, for example, stopping a machine or sending a mechanic or something like this. So that's basically it here. And what's also, again, very important, what I have done here, I have implemented the patterns with configuration here. So I have configured my sliding windows directly in here, and also the patterns, which we found out by the business user. But another example here is where we use, for example, the TAR component. And the TAR component is a component which really executes the R model. So here you see on the bottom, this is the fit.R data. This is really the analytic model which we have seen here in the R Studio. This was saved by the data scientist, and without rebuilding it, you can reuse this model, this analytic model. So this is the closed loop which I talked about, that the data analyst and the business user define the model, and then it is deployed to real-time processing without changing this model. And that's really the key. And afterwards, the closed loop continues, because then you want to improve the model and validate it all the time, because things change and you have to rebuild a model. But the important thing is that you do not have to redeploy or re-implement the stream process. You just deploy the outside model again to this process to execute it again. So that's basically the live demo. I hope you got a little bit about a feeling about how this works in a real project. So what I've shown here to you is a proof of concept we have done for this customer before he bought our product. And as you saw, it's a very simplified version, so it's just a proof of concept. The real project, of course, then is more complex with more complex rules and all of that. So let's finalize this with the key takeaways. If you go out here and just remember 3 things, I of course hope you remember more, but the 3 keys are really: streaming analytics processes data while it is in motion. You do not write it first to the database, no request response, not like web services. You really aggregate and correlate it and do continuous queries while the data is in motion. Only this way you can implement most of the use cases, like cross-selling, like fraud detection, like predictive analytics, and so on. And as I said, in most of the use cases we see at customer, it's very important to also offer human interaction in a live UI where the events are pushed to Again, not request response, but push the real-time information into it so that a human can also interact on that. And I hopefully have explained you very well that also streaming analytics or stream processing is complementary to the other big data parts, like the big data store in Hadoop where you store the terabytes of data, and like machine learning with R or MATLAB or SAS or any other technology. This is really complementary, and all together is the closed loop which you use from historical data, finding the patterns and bringing them into action, and then improving it again. So that's in the end a closed loop I wanted to show you. And the time is also over, and we have lunch time now. So I recommend if you have questions, come to me back afterwards. And now let's say thanks to Northpoint for the lunch sponsoring, and thanks a lot for your time.